Okay, I hope it is visible to you all.
Yes, sir.
So we were discussing about the safety improvement by using AI-enabled technology. So we know that there are a lot of safety concerns as far as EV is concerned, right? Once we are comparing the ordinary cars and electric car, people are still have doubt that there is a risk issue, there is a fire issues in electric vehicle because of batteries and all, but it is all myth, right? So by enabling AI technologies as far as safety concern is there in EV, we can have a real-time hazard detections, just like we discussed a state of health and state of charge kind of concepts. So that real-time hazard detections can be identified. AI powered driver assistance systems, because generally the over time driving also creates a kind of accidents. So with the help of AI driven advanced driver assistance system, that will improve the existing usage or existing energy of driver with the help of facial expression and the tiredness that is available. Emergency braking systems, lane keeping system, adaptive cruise controls, all things can be identified. And in case of any emergency, this AI enabled safety devices will respond very quickly in comparison with other ordinary cars, and it definitely helps to provide a full sort of support in line with sensor fusions, augmented realities to guide the first responders to handle the EV incidents and all. So there is a burning issues, I guess, in Ola S1 when Ola S1 was launched. There was a lot of burning issues that needs to incorporate with an augmented reality based guidebook to justify the safety improvements. So we are at sixth number point, that is smart sensor integration. And by enabling smart sensors, we can improve the overall usage of AI, right? So how we can incorporate AI enabled technology? Maybe the first step is smart sensor. I hope you all can see my screen. I'm at point number 6.
Sir, it's point number 5, the safety improvements enabled by AI.
Okay, now I guess
Yeah,
now it
now
is
it's
point number 6, right? Yeah. Okay, okay. So the diverse sensor type in student EV system, which enables lot of smart sensors like GPS, IMU, that is light detections and ranging, the cameras, so-called smart cameras, the GPS systems are there. AI-driven sensors data fusion, that lot of data are to be gathered with the help of AI-enabled technology, with the help of multiple sensors, and that enables the real-time multi-sensors fusion. Improve the simulation awareness. So depending on the situations that, let's say, with the help of GPS, Google Map, we can identify the number of traffic, in which route it is more traffic and all. But we can identify the real-time situations which synergize the smart sensors with the help of AI fusion, which allows a 3D environment modeling. Right. So there are a number of software. We'll try to discuss that software as well, if time permits. So through that software simulations, we can incorporate how this AI technology is enabled in EV, right? And innovative application in safety, just like in previous slide, we had verified the advanced features for lane departure, pedestrian recognitions, augmented realities that can effectively be justified, which is not available in non-AI based automobile vehicles. Either EV or non-EV doesn't matter, but if AI enabled systems are there, then some sort of improvements or innovations are there as far as safety is concerned. So a kind of examples which we can incorporate by having AI enabled EV, so-called student driven EV, we can have a secure data acquisition. We will be having a reliable data communications, artificial intelligence algorithm. Now there are n number of algorithms are there. Depending on our need and applications, we can use any. Control system mechanisms again and methodologies are there, and battery management systems. So now all datas are through server, we are connected to the cloud. So all EVs are being incorporated, are in connection with each other, and depending on the availability, resources, and the applications that we are in need, we can incorporate effectively. Autonomous and semi-autonomous features of AI-driven system. So it do have certain examples like AI-driven navigations in the student EV system, challenges in automobile EV development, and a smart driving functionalities are demonstrated. So that 4 or 5 philosophies are there, detailing are there in upcoming slides. We'll have a detailed discussion on it. Again, in the beginning of the presentation, I mentioned that vehicle to everything communications are there, like V2X, just like P2X is a concept, power to X. Like from power, I can have an N number of applications. Same way, here, AI enabled vehicle, so called EV, will have V2X kind of communication. So, what is that V2X concept? Let me just give you brief, because all European countries and developed countries are using this like anything. Okay, in China, 97% penetrations are there in EV, right? So almost out of 100, 97 people are using EV only, and the technology are at saturation level there. India, we are working somewhere in 10 to 11% penetration, right? So there is nothing wrong to learn from developed countries. They are having this concept V2X communication. It means they are feeding energy from their existing electric car battery to the grid. And when tariff rate is quite less, they are getting charged back to their battery and they can use vice versa. So that technology is very mature there. And right now we are working one pilot. Recently we have submitted one proposal to BEE, and hopefully we'll be getting a grant that we will be setting up that same concept V2X kind of technology in one of our campus, right? So the role of AI, as far as communication system is concerned, multi-sensor technologies need to incorporate with an situational awareness, optimize the communication protocols, and support a predictive analysis with a dynamic selected communications technology to improve the reliability and the safety aspects. For that, as we are dealing with an AI, data collections, data monitoring is very, very important. We need to train our AI model that you need to perform this task, not this one. Okay, this is right, this is wrong. So I used to compare AI with a small kid under the age of 5, 0 to 5, right? We need to train them, we need to instruct them, this is right thing, this is bad thing. While crossing road, you need to check both the sides. While playing in a ground, you need to take care of all insects and all, something like that, right? So just like that, a kind of concept of narrow AI, right? General AI, narrow AI, and super AI. That three classifications are there. Narrow AI incorporates with a specific task, that this is right, this is wrong, do like this, not like that. Kind of concepts can be incorporated. So for that, data monitoring matters. We need to provide huge amount of data to our AI model to train the particular application performances. Software and hardware platforms for AI integration. So as I mentioned, smart sensor is an initial stage or ABCD to enable your electric car with the help of AI technology. So student build EV utilize the platform like MATLAB Simulink. I hope all of you are familiar with that. And one separate tool is also added in MATLAB Simulink in the updated version AI, right? So-called genetic algorithms or optimization algorithms, it can be incorporated effectively. Just give me a minute, okay? Just give me a minute. Hello, am I audible? Hello.
Yes, sir, you're
Yeah,
audible.
yeah, Ishika, extremely sorry. I was having an important call. That's why I need to pause the presentation. Okay, let us continue with our discussion. So we were somewhere in the software and hardware platform for AI integrations. So just like in previous slide, we had discussed about the smart sensor mechanisms. So smart sensor is a kind of initial stage to incorporate AI-enabled technologies in EV, right? So that can be effectively justified. As far as hardware consideration is concerned for AI integrations, there are a number of hardwares are available. Let's say, for example, GPS is a kind of device or chip that we can incorporate within AI systems. CPU mechanisms will be there, GPU mechanisms are there. Even AI accelerators to enable real-time fusion systems are also incorporated effectively, right? Balancing of computational power and energy, just like we had verified the state of health and state of charge concepts of battery management systems. Here also we can incorporate the real-time monitoring of temperature, so-called thermal limits, current and voltage from an individual cell, and we can execute a task like cell balancing mechanisms, the equal usage of power, the equal drainage of energy from a particular cell. That thing can effectively be incorporated. So this is one sort of examples like how that big data, so-called data management systems, helps to effectively enable AI technology as far as EV is concerned. So cloud transforming data to control, as you can verified, all data are bidirectionally in nature. So what kind of information we can incorporate? Enhancing AI models through IoT enabled data collections, predictive maintenance and full diagnosis, and a fleet level optimizations and connected EV systems that will be fed to the cloud. That cloud will be enabled with the help of different EV subscribers, and that can justified with the big data analysis in line with volume, velocities, veracities, and varieties. Okay, and likewise, it can provide some sort of visual impact in line with some graphical representations. Then there will be a kind of real-time information of state of health, state of charge, and so-called data management can be identified. Here, if you all can verify a real-time monitoring as far as renewable energy is concerned and battery management system is concerned, that also is now enabled. Recent notification by Ministry of Power that all renewable plant must have 10% of total plant capacity as in storage capacity, which can be helpful for the peak demand balancing, peak load demand balancing, right? So that is effectively justifiable here as well as far as EV system is concerned. Now, very interesting part as far as student community is concerned, always try to focus on the problem statement, the challenges. So challenges in applying AI to your particular vehicles. We have a number of challenges available, starting with technical limitations and resource constraint, right? Fund availability may be the big issue. Lot of organizations are providing n number of funds to prepare a pilot or develop a prototype which is AI enabled EV, right? So starting with that, again, which algorithm is good, which hardware is to be incorporated in line with an energy efficiency and sensor integrations, which protocols needs to incorporate. These are the technical limitations, right? But again, believe me, depending on the detailed literature survey and the actual problem identifications, it has effectively been nullified. Data privacy and security concerns, right? Dealing with AI is now a risky because cybersecurity is a concern. What if your cloud will be hacked by someone who is cyber experts and will malfunction your data, right? As per this image is concerned, all your car vehicles informations are available on cloud, and according to that we can provide some sort of big data in line with visual impact, their health monitoring in line with state of charge and health, that can effectively be nullified. So that will be the issue: data privacy and security concerns, and ensuring a reliability of the AI system. How much accurate your AI enabled EV is, right? Because just like riding a cycle is okay, we know depending on our energy, we can ride a vehicle. Now, what if your AI, which is having smart sensors, will sense a wrong information? So-called garbage in, garbage out. If you are feeding wrong information, it provides you a wrong output, right? So ensuring the reliability, we need to cross verify the same whether our system is reliable enough or not. Okay. And specific challenges in line with battery management system. The three main domain in which researchers are working their PhDs and master studies, right? Like battery degradations and state estimations complexity, energy efficiency and safety requirement, and operational variability and real-time decision making. Like now, ultimately, we are training our AI algorithm in such a way that it will take a decision. It will try to incorporate, diagnose the fault, and it can take a decision in line with an result, right? So that all things can effectively be justified. So this is quite particular challenges as far as battery management system is concerned. But yeah, we can choose any one as per the technical feasibility, data privacy, security concerns, and reliability issues. Some case studies I would like to enhance as far as European countries concerned. Lot of good results we can identify, but let us try to talk about Indian market. So top three engineering innovations. I recently got this article from one of the magazine, and three institute has under student startup cell. They have prepared a very good AI enabled EV projects. These are listed over here. IIT Madras, I guess you must aware, Hyperloop inspired by EV Pod. That is the name is Project Prana, right? It incorporates with five main impact as far as the subtopic is concerned. Innovation, that magnetic levitation assisted drivetrain reduces the friction and boost efficiency. Design, smart tech that features the onboard diagnosis and smart grid connectivity, like where your charger is, how long it takes time to charge your battery, and all. Sustainability and the impact, right? The futuristic efficiency, eco-friendly mobility. Again, the big concern of battery degradation. Okay, battery degradation can also be incorporated with AI enabled project. Again, second institute, BITS Pilani, the modular EV platform for the rural mobility. Particularly for NSS team, they have incorporated from like rural area, the impact of EV in rural. The modular design was of two-wheeler to cargo vehicles on a single platform. Battery swapping technology they have enabled with the low infrastructure areas, not just like a big battery swapping unit. A small capacity battery swapping technologies has been adopted. Affordability, smart maintenance, and the impact is a scalable, sustainable solution for last mile rural mobility. Right. So particularly for rural applications, how that has been incorporated. And DTU, that is Delhi Technological University, a Formula E car, I guess more concerned with your domain of expertise. The Voltex is a student engineer Formula E car. that builds to push performance boundaries and inspire the future EV technologies. After this project has been executed, Mahindra has tried to approach this team and they want their IP rights from the team, right? So again, just for reference, the motor control mechanisms, the regenerative braking technologies, the real-time telemetry mechanisms, and aerodynamics kind of philosophies they have incorporated. And again, the impact are in front of us. The high-speed test, advancing commercial EV materials and safety systems are more or less incorporated. Little futuristic vision, if we can identify it, as I mentioned, this is a general presentation which gives you a glimpse about the impact of AI for EV. So the futuristic impact will be an integration of AI with renewable energy. The amount of energy available from a particular renewable plant to charge your vehicle and vice versa. So vehicle to grid, grid to vehicle integrations within smarter and cleaner transportation mechanisms. This is a futuristic technology. Government is ready to provide fund to prepare a pilot on this, right? Again, I'm from Gandhinagar region. PDPU has recently submitted a proposal to the state nodal agency on this topic, renewable integrations with the help of AI enabled EV. Advancement in AI powered battery management system, right? A real time monitoring in line with battery safety, lifespan, and the performance by predicting thermal event and optimizing chemistries for the faster charging. And last is advanced autonomous driving and so-called V2X communication, vehicle to everything, that boost the traffic management and road safety. One simple example I would like to address here, that allowing your electric car to enable a CCTV camera on your car, which will help and monitor the traffic police personnels who has weird seat belt, who has weird helmet or not. And through your CCTV camera, which is available in your car, they will generate a memo, so-called a kind of fine to the third party who has not followed the traffic rules and all. So this is one kind of simple concept, V2X communication, right? So need to understand how we can uh, avail a procurement of that. Whether are we eligible to fixed a CCTV camera on the top of our car? What will be the range and all that philosophies. So this people are working right now. Okay. Uh, Before we conclude, the very impactful and very sensible topic as far as EI is concerned is ethical and societal consideration, right? Ethical EI use for vehicle control matters. Bias mitigations and fairness also matters because it must not be a kind of technology proven. So there is a monopoly of one field, another field is having a in a minus term to encourage ethical AI usage, renewable energy integrations, and autonomous driving explorations, and the continuous AI modeling that trains to advance the sustainable intelligence mobility. With that, I guess I'm concluding. This is my contact information, email ID. If you wish to explore more on any of the topic listed over here, we can have a separate discussion, or I maybe it's totally fine from organizer, and if you can share my email ID with the participants, would be happy to address their queries and comments.